right. Hello, everyone. You can hear me? So, I'm Lorraine. I'm from South Africa. And I've run a software company for actually 33 years. Still do development. And my interest in systems thinking was really because we're in the business of solutions. So I guess you're also interested in it. Maybe you're not sure why yet. Let's see if we can explore that a little bit. When we're born, as children, we tend to have an intuitive understanding of systems. If I put a tree up, everybody gets it. You know, you need water comes from roots, goes to branches, seasons affect it. And we're quite good at looking at the bigger picture, how the whole thing works. But as we grow older, we get taught to analyze things more and more. And analyzing things is about breaking it down. And I think we start to lose that ability to see the bigger picture. Now, we spend a lot of time in DDD as well. We're saying, find the bounded context, try and break things up. And it's very good, right? Because that's all our brains can often cope with. But I just want you to think about systems thinking as a tool for sometimes stepping back and getting a broader picture of what's going on. All right. And this, I've maybe said it a little bit, but it's because we solve problems. I mean, it's a bit of a jokey slide, because hopefully we're helping our users through DDD to actually understand how we're doing it, and we're getting our language better. But I think there's really a place to talk about what's problem space and what's solution space. Right? There's more to come on this slide, so those of you going clicky, give me a few more spots. And please tweet. I think I went a little bit fast, but it's law_KRS. So in the problem space, that's your user space. That's where they should be explaining to you what is the problem. And we should be looking at how can we solve it best. But often, what I've had in my career, is people say things like, or users say things like, I want this, whatever this is. Now they're actually defining the solution. I have no insight into the why. I mean, maybe you can guess and all of that. It's a bit of an old example with prints, but I still get these kind of requests. That one it's a little bit better as a warehouse manager but it's still defining the solution, what they want. Right. So I'm saying that when we want to look at a system, it's most important to keep focusing on what are we trying to achieve and not allow this kind of railroad us almost into one solution. So let's introduce you to what makes a system. How do we define it? I'm going to introduce you to the upside-down triangle. At the top, I suppose I should, there's a screen as well. I actually did not work out where all my views are. At the top are the elements. So that's easy, right? We actually all do that all the time. Those are your entities. Those are the things you can generally see. We're quite good at that. A little bit more subtle are the interconnections. So in my tree example, the elements is the leaves, the branch, the roots, the trunk. The interconnections is how does the water flow? How does it reach the leaves, the sunlight? There's other stuff going on. A little more difficult to see, but still detectable. The most interesting one is the purpose, because it is the purpose that makes that a system. Otherwise, it's just bits, right? Maybe I can explain that a little bit more clearly by using the car example. If my purpose is to safely transport people, and the system we're discussing is the car, I can't really leave out any of the bits. I mean, if I left out the airbags now, it might not be safe. If I left out the little side mirrors or something, that wouldn't be safe. So it needs all of it to be the system, because that is the purpose we defined. So depending on how you define the purpose, that basically includes what's in and what's out, which is why I keep coming back to purpose, because if we don't know why we're doing things, we will generally come up with wrong solutions. Systems, almost as soon as you come up with some idea, that system it takes on a life of its own, right? So, and the trouble with systems is they're actually very difficult beasts, right? So a lot of things go wrong. So we have a sort of Murphy's Law approach to it, which says, if anything can go wrong, it will. I prefer the one from Systemantics. It says they're not actually malignant, they only seem so. Right? So let's talk about some of the things that can go wrong in systems language. Now, I know you're going to like this because it's patterns, really. And everybody in DDD loves patterns. So here's your first pattern. These are sometimes also called systems archetypes or traps. Policy resistance. So my example, the USA's war on drugs. Okay. The little blue line is the addiction rate. So apparently the more money they poured into fighting drugs, the addiction rate stayed the same. So what's happening here? What's actually going down? There's obviously quite a lot of stuff. But here's one of the things that's going on, is we've got escalation. So, the good old English cop started off with a baton, then the crooks got guns. So then the cop got guns, then the crooks got bigger ones. And eventually you've got a guy in full riot gear, and you're not in touch with the population anymore. So that's the escalation pattern. This is a little bit of a South African example for you. About 2 years ago, we almost ran out of water in Cape Town. And we had something called Day Zero, which is the day the dams were going to run out. Now, as a city, facing the idea that you wouldn't be able to open the tap, finally everybody panicked. But it actually took until we were faced with Day Zero for people to change their behavior. Because the Commons says we're all using some resource. In our case, it was water. And if I water my garden, that can't really make such a difference, can it? Right. And when you have 3 million people all with that same attitude of my little bit can't make a big difference, you just keep on using up the water. And it was a really interesting thing. It was actually the government built a water collection point. And everyone was like, you mean we'd have to go and take our 5-liter drum things, 10-liter, whatever, and queue? And everyone suddenly switched off the taps. And it took something like that. So the other things that were, it was called the commons. The common was the common ground in the meadow. So if I've got a cow or whatever and it's grazing, and then my neighbor brings theirs onto the common, and after a while I'm like, hey, I could keep 2 cows. My neighbor says, hey, she's got 2 cows, I'll keep 4. And after a little while we've grazed that field, finished, right? It's done. So the point of commons is that we don't appreciate the cost until they've been abused. Now, each of these patterns has a solution. For the commons, it's you've either got to change, you've got to work out a way to charge people for it. And we do that very successfully with parking meters. In a city, there's only so much parking. It's a common area, actually. I mean, we've long since stopped thinking about it like that because we're used to parking meters. But what we've done is to use your little 3 meters by 2 meters square for 2 hours. You've got to pay for it. But now, as soon as we came up with the solution of making you pay for your parking, which is a common area, the system got a life of its own. We now had to have people enforcing it, writing out tickets. This is the trouble with solutions. If you can't think about them in broader systems terms, and believe me, that system will need, the moment it comes into existence, it needs maintenance. It needs looking after and support. This is a pattern that we see everywhere, success to the successful. It goes like this. Let's say you are a second team player at school, whatever sport it is that you play. but the first team is getting the good coach. Right? So the first team, in our case, we're all rugby mad. The first team at school gets the good coach. So do the second team kids get the same opportunity to improve that the successful kids are getting? Right? So who's in the first team next year? Well, the guys who got the good coaching, generally. All right. And success to the successful, I think we all know. If you were born with money, it's a hell of a lot easier to make money. This is one I like you to think about in your teams. Shifting the burden to the intervenor, or the hero trope. So the hero is that guy in the team. Hey, excuse the language, but it's usually a guy. You can take it as gender neutral if you like, but who says, don't worry, I'll fix it. I'll do that. So there's no knowledge sharing. And if that person leaves, the whole team suddenly is like, we don't know that area of the system because this person always helped out. So that's not positive help, right? That's negative help. So the intervenor is a very dangerous pattern to look out for. And we fight it with pair programming. Lisi did a wonderful presentation on mobbing yesterday, all those good things. But be very careful of trying to be the hero, running in to rescue people. Because their ability to recover, to sort of stand on their own feet, then degrades. Yeah, busyness rather than effectiveness, we all know this one. Although we know it, seeking the wrong goal, like looking busy rather than getting things done, it's a very pervasive thing in business. So if we know we're in the knowledge business, right? We're supposed to be knowledge workers. But if you were sitting at your desk with your feet up, and looking out the window, I mean, how many people have got a boss who'd kind of go, aren't you working? Yeah? Anyone? And the thing is, when do we think, right? We're supposed to be looking busy so much of the time. So, just think about that and what we do with our time. Can you see this? Rule beating. Kids have got it nailed. So this one was, the intent of the rule was write a letter home to your parents. So the kid writes, I was forced to write this to eat. In case you can't see it. So they obeyed the rule. But the intent, that the parents get a nice warm feeling and the kiddie's happy at camp. Drift to low performance is making excuses. So the pattern is called that. It's quite a nice name, but essentially it's about making excuses. The economy is bad because the oil price went up. Okay. Oh, it's not in our control. Now we do it in business. Our results were not so great this year. Economy is down. But actually some companies flourish in a poor economy. Okay. So, yeah, humans, eh? We're very good at making excuses for ourselves. It's more comforting. And what you have to do is consider, how do you keep your standards high, essentially, and from the micro to the macro level. Okay, so those are some of the things that can go wrong. There are more patterns, but I don't think you want to only listen to the what goes wrong. Though it's funny in systems thinking, we have more patterns for the negative patterns and for positive. So I want to do a little exercise with you. I'm hoping you're willing to shout out some options. Let's try a little example about how does this become misaligned. What do you think the purpose of a university is? To grow talent, nice one. Teach people. To keep the knowledge alive. Any other? To socialize, yeah. Research, okay. So there's a lot of different possible purposes that we've just identified. I found this rather highfalutin, fancy one on the internet somewhere. Yeah, this is the kind of place that thinks it's the owner of reason and research, right? All these things. I think you'll get a much simpler answer if you ask the students. What do you think the students say? Right. We're starting to misalign purpose. Yeah? What do you think the accounts department at the university says is their purpose? Yeah, that was the answer down here. To get money. And that purpose is actually directly at odds with the others, because they're there to kick the students out if they can't pay. Now, there are some countries, I think, that have solved this with free tertiary education or bursaries or other ways of helping. But if you have the old-fashioned, you will pay for your university kind of system, the accounts department's not your friend. So we get that in business. I see admin departments sending out these forms that you've got to fill in, and I'm thinking, why are they making me do their work? Because, their purpose was to collect it. They don't mind that they're taking away from my team's productive time, because our purposes as departments, as groups in that company are now misaligned, right? And KPIs drive misalignment, because your purpose now becomes to satisfy your KPI. And there's a lot of, I'm trying to remember, it's Deeming, who writes a lot on systems and cannot stand KPIs. Is everyone familiar with that term, the key performance indicators in the job? And he says they're evil. I like him. Let's talk about short-term thinking. Around about 1900, so a long time ago, society was really, really worried that we would have killed all the elephants within the next sort of decade. And that was because so many things used ivory. The piano keys used ivory. The billiard balls used ivory. There was actually a lot more subtle stuff. Combs were made of tortoise shell. We were killing tortoises for their shells, right? In a pre-plastic world, we were using up the animal resources. So in 1907, when Bakelite was invented, which was the first kind of hard plastic, everyone thought this was a good thing. It was going to save the animals. Yeah, how's that working? I mean, it's not even funny, right? Because we didn't look further. Yeah, we invented it. We didn't think about how do we destroy it? What happens to it? I mean, it blows my mind that in the last decade, we got so excited about these little microbeads in like face creams and stuff. And it was all the women's products. Maybe you guys don't know this, but hey, I'll tell you as a woman. The face creams and the washes and everything have microbeads. And it was like nice, it really made the skin feel good. And then everyone was like, oh shit, there's microbeads in the sea now, We keep doing it. It's not like we only did it in 1907. We keep doing it. We come up with something and we don't think about what next. Okay. Let's do some more businessy examples. I'm getting to the end of my bad news bit. So Kodak, I think we all know this story. They actually did invent a digital camera, the first digital camera. Because I think you all know they kind of went out of business because of the digital camera. And the people didn't want film anymore. And the funny thing is they had the first one. It was a little big and clunky, yeah? But a 24-year-old engineer invented the digital camera for them in 1975. Yeah? They had it. It was right there. And what did management say? Well, the trouble with when was it? 1975, is there weren't really monitors. There was your TV screen. And they were like, why would anyone want to see the pictures on the TV screen? People love photo albums. This is what people love. I don't think this thing's got much potential. Then in 81, Sony came out with something, and they were like, yeah, maybe, maybe. Microcomputers were there, screens were changing. But you know what? We got 10 years before we have to worry. Anyway, they didn't worry, because now once you've made that decision that you've got a long time and you don't have to worry, you don't worry, right? So what is it? 2012, filed for bankruptcy. And that's sad. And there's a message in there. It's our decisions that make things fail. So they didn't fail because the market found digital cameras. They failed because of the decisions they were making. Now, this might make you feel a little bit uncomfortable, but a failing project is due to our decisions. Does it make you feel uncomfortable? I mean, usually for most of us, it's not us, it's management. But it's somebody's decisions. Okay. Yeah. The thing is, actually, that's also the good news. Because if it's our policies that cause our success or our failure, we could change those policies. Yeah? So, I mean, this is where I really got excited about systems and systems thinking. Because I've spent too much of my life, and in our company, we were doing a lot of workshops. We were training people. So every Friday afternoon, you could get yourself a drink, and you could attend the workshop, and we'd be introducing some nice tech topic. And then we'd done that for many years. And then we noticed as we got bigger, there were more and more people in the back who seemed to only be enjoying the drink and falling asleep. So we said, people aren't really interested in learning. Yeah, get yourself into those things where you now start blaming the people. And you must be very, very careful because it was the way we were doing it. If you really think about it, the system we had set up to impart knowledge wasn't working for everybody. And I like to try and keep swapping that because otherwise you end up with those dialogues that say, gosh, I got a lot of lazy people. My team doesn't want to cooperate. Yeah, it's actually our decisions, the way we create these structures. So let's do some practical stuff, a little bit of modeling. At some point, I'm going to make you also shout out things for me. I'm just going to give you quickly some how we do systems diagrams. And it doesn't really matter. Huh? You can draw any blocks. But this comes from this really lovely book, Systems Thinking by Donella Meadows, which I think a lot of you know. And I just like her diagramming thing because it's nice and visual. In the middle, we have some or other stock. So the easiest one to understand is the dam. You know, there is water, rain, river comes in, so that's the taps. And it's a tap because it can be more or less, right? So you think of that flow, is it a strong flow, a weak influence? And you take things off. There's some evaporates, some we use, some we overuse, and we end up in day zero. But you know what the most important part of this diagram is? Those little clouds, those are boundaries. Because if I'm going to look at the water system, I'm trying to figure out why are we overusing it. I mean, where do I draw the boundaries of what I'm going to consider? Is it the industrialization upstream that has caused the lower flow? I mean, next thing you start looking at everything, right? So where you draw your boundaries is very important for the problem space you're going to deal with. There's another big part of the diagram, which is your feedback loops. So that initial one had no feedback loops. In theory, we could have just turned the tap and emptied the dam. Now, we don't want to do that. So we've got two types of loops in systems. The balancing loop's really easy to understand. I am cold. I put on a jersey. I feel fine again. We've brought my temperature back to where it needs to be. So that's a balancing loop, a thermostat, anything that's just we have a problem, we fix it. A much more interesting loop is the reinforcing loop. So the way this goes, the easiest one to explain is the birth rate. We have a high birth rate in a country. Medicine's improved. Lots of children are surviving, more than they did before. This is particularly relevant in Africa. So the next generation has twice the number of grown-ups to make more babies, which means we have even more. So you quickly end up with these overpopulation problems. It can also go the other way. I think we've got some countries, I think you have in Europe, where the birth rate is now not at replenishment rate. Okay. So a reinforcing loop can work both ways. It's like compound interest. In a team, it can work very, very negatively very fast. So if you have bad attitude, like a negativity going on the team, that spirals downward, sucking everyone in with it, much, much faster than your efforts to like pick everybody up, right? So bad news basically travels faster. So if we make a slightly more complex diagram, it would look like this. Cloud, boundary, what comes in, some kind of stock, the thing we have. Something goes that's pulling off it. And to be a system, it must have a purpose. Yeah, no purpose, no system. So now we have a discrepancy to that goal or purpose we have. And we can put a B or an R for balancing or reinforcing loop to show that this, whatever it is it to this side or to that side, wherever our feedback loops apply. Okay. So very sort of simply. Everyone, you're happy that it's boundary, taps, central thing, some loops. So now we're going to do a case study together. Okay. Let's see if we can do this. I want you to think about a team as a system, right? Just because, does anybody here think that you're in the technical business, by the way? Do you think if you're in IT, you're in it? Because I think I'm in the people business. I think everything's about people, right? So that's why I picked the team as an entity for us to try. So if I have a team that's not that effective, and I wanted to try and look at it from a systems point of view, what would I have as my stock? You'll have to shout. No wrong answers. People. Okay. Team. People. Yeah? Sorry? Time. Yeah, I suppose everything. I don't know how to model time. Don't think any of us do. It doesn't really show in this one. Motivation, right? Is that an input? Would that come in on my little tap? That we can motivate people. That's a tap. Sorry. You'll have to just believe me. There's a cloud. Right, I love that. Motivation. That's an input. Knowledge, love it. Safety. Ah, I like you guys. Trust, yeah? So it depends what we're modeling. If it's the team's like energy, the effectiveness, it's not actually the people, then frustration would be something that reduced that effectiveness, right? So one of the ways I could say here, it's the team effectiveness, because that is actually more of a precious resource, right? That is our resource that we could look at. And then we could say this draws off via the little tap. Okay, that frustration I didn't say I could write neatly. Draws off. Love it. Interruptions. Management decisions. So I put that here, right? I mean, it's, yeah. Can I call it policy? All right? So the policy of the company can absolutely change everything. If you decide you're not paying overtime, yeah? What happens here? Oh. Yeah? What are politics? Trick question. I mean, I define it as a lack of knowledge sharing. If everybody knows everything, there is no advantage to be gained in what you know that someone else doesn't. You want to solve politics, you tell everyone everything. Take it, but that's my hint for you. Disputes, I heard, sorry? Yeah. So the alignment, the I think that almost goes with motivation. You're motivated, you're aligned, you've got goals. Yeah. Now, we somehow need to figure out our loops, because what we've said is there's something wrong where the goal was working software. I don't know, what would effectiveness maybe produce solutions, it would produce something. We have a gap, which is that we're not getting what we expected, so poor quality or not solving the problem or something, and what we're going to try and do is improve things on that side. So that's sort of, okay. Now, you've been a very good group. You didn't get too tied up with small details. I've done this with other groups, and one of the inputs to the team was coffee. I think this group has actually tried to look at it already from a higher level, right? I mean, I put one up on the slides to try it. But yeah, if effectiveness was our stock, our resource, and just basically I eventually reduced most of that to what are the policies? What are the people that are coming into it, the policies, the people who are leaving, communication, It's not necessarily supposed to be a perfect diagram. It was to try and simplify it back, because how would we know when we have that much to deal with, where to start? So this takes us to the sort of second half of what I wanted to really talk about. Oh, there's a final one on Conway's law. You all know it by now? How many times has it been repeated at the conference? 5,000, right. But if you've got an organization where people aren't speaking at each other and they're all holding each other off at sort of gun, shotgun length, you know what happens. So because the most common thing when we model is we start putting too much in, I wanted to spend some time on simplification. So I've run this workshop a couple of times, and whenever people actually themselves now start to try and do the diagrams, it's not as easy as when someone else does them. All right. So let's just look at some of the ways we could organize our thinking to keep that simplification thing. One of the greatest mental exercises that a lot of people consider was Newton's theory of gravitation. It's going back to why I have planets and suns, right? Is that in, how many, 400 years ago, figuring out how gravitation worked was a really difficult problem. And Newton looked at this and he went like, I think the sun is dominant. Yeah? This is the biggest entity. We don't actually have to consider the hundreds of thousands of combinations of planets, stars. His genius was to recognize that we only have to consider the forces between the planet we're looking at and the sun, because it was so dominant that nothing else mattered materially. Now, he wasn't 100% right. Right? With computers, we've been able to refine that to take a lot more into account. But we're talking, 1687? There was no way manually people could have done all those calculations unless somebody had had that insight to say, I can deal with this problem in pairs. So when we, as an industry, and we're still getting this wrong, aren't we? When we overcouple things, we can't really solve it after a while. So everything we do, every bit of DDD, clean code, all of the rest of it, eventually there's just two messages, wasn't it? It was high encapsulation and low coupling. I mean, haven't we been saying that for about 40 years? Right. So he got that low coupling bit, right? So how can we take that ourselves and use it? Well, this person did not get it, right? It makes me despair for the world when most of the stuff we're presented with, people are actually kind of quite proud of how complex it is. Look at all the work I did. There are some rules. When you're diagramming, there are actually some simple rules. So I put them here just so that you have a checklist. That's basically, less. Don't cross. Our brains don't like it. Do you know why we need less coupling? Is it for the computer? No, that's for our stupid heads, you know? It's all for us, right? So we're using modeling because it's going to help us understand this scenario. We're going to use our little clouds because it's going to bound it and we don't have such a lot to consider. So keep things straight, keep it small. What else was it? Parent. Parent is like your most important entities. Typically get them in the top left or top right. I don't really mind, but I read left to right. And keeping it tidy. Now, when we don't step back and look at the bigger picture, when we just look at small things and we're trying to make them better, the danger is that we're going to just do that thing more right, but it might not be the right thing. So as much as all these feedback loops are fantastic, I've sat through too many agile retrospectives where we just try and get our ticketing system better. We just try and get everybody to actually use it more. Or we don't very seldom say, should we have a ticketing system? But we all love Jira. So, then you just think about that one. So again, systems thinking is to make you step back and say, are we doing the right things? I've already mentioned the power of twos, trying to get things down to pairs if you can. What affects what? What is the major effect? Our brain is so good at patterns. First impressions here should, I hope, be sort of green and red. Oh gosh, this is probably terrible. Who's colorblind? I'm so sorry. Sorry. It's green and red. But it's not just green and red. There's actually subtle subcolors. But our brains automatically make patterns. We're wired to actually detect patterns. So if you can use some of your intuition, remember right back at the beginning with the tree, I said systems thinking sometimes means getting back in touch with our intuition rather than just trying to analyze it all to death. But if you can single a thing out, it's even more powerful. If you can turn it into twos or patterns, that's powerful. So these are techniques for simplifying. You know Occam's razor? Yeah, some? No? Only some, or all. Occam's razor is a concept that says, basically, the simplest solution you can come up with that solves everything, not leaving anything out, is probably correct. And I've always thought that was quite a nice saying. But then I sort of think, why? Is this just a saying or is it true? Right? What makes it true? So it turns out mathematically it's actually true. And it comes down to probability theory, if you like. The less assumptions you've made, the more likely it is to be right. Every time you add some more complexity, it could be this, could be that, the answer is more likely to be wrong. So I'm really chuffed about that. Occam's razor actually stands up mathematically. So you want to drive to simplicity. I also use this one, the Pareto rule, the 80-20 rule. It's not just, I think most of us know that the last 20% of the system takes 80% of the effort. That 90% done is a lie. But I use this a bit differently. I think it should be identifying where you get the biggest benefit. So what I've seen is that we often, whether it's the key user interface that we're going to, is going to be hit thousands of times an hour, or it's the stuff for the accounting department that runs at month end, we tend to write that code the same. We put about the same amount of effort into it. We write our tests, we analyze. But actually, we should be putting more effort into the thing that's used most. It's like we just have one way of working often. So think about that too. Think if you can use the 80-20 to leverage your time for effectiveness, rather than sort of solving everything the same. Okay, so back to that little picture. We're still saying less is more, pairs are better and singles are better. But keeping things straight is mainly in your head. the most important first is like the Pareto rule. Try and find the way to simplify this, what really matters. Well, if the knowledge is a real problem, it looks like an easy one to solve, it's fairly tangible, what can we work with? Get to the most important. And in terms of tidying, for me, it's always about one's own thoughts. I was always a person who used to format my code before, someone else's before I'd work with it. Now at least we have IDEs that do that for us. But I have been known to sit there indenting stuff till I could deal with it, right? And then look for the feedback loops. If you have, and the crowdsourced stuff, what makes some of the Google Maps and these things so amazing is that they actually, sometimes they used to ask you, was this route good? Right? So they sort of check the algorithm against the user's experience. That's powerful. How many of us do that? If you have an opportunity for a feedback loop and you don't take it, and we often don't because it wasn't defined by our user. But resilience, so that gives your system the ability to recover. Okay. Some of the resources, we should really add deeming to that list as well. And I put my slides up on SlideShare. It'll be available via the conference if you want these as well. There's so much good material about systems. And so many great thinkers. So I'm just hoping you put it now into your toolbox as a way to step back. So remember, when you're looking at a dysfunctional team, a dysfunctional system, a dysfunctional whatever, it's behaving as it was designed. Okay, just not as it was intended. That's basically me. I'm happy to take questions. Yeah, it's time. Is there anyone who would like to ask anything? It was a very fast run through systems, so I'm sure you've got. Yes. Yeah, pretty much all the time. So the question is, how often do we experience conflict of interests? So I've got a very firm view that if you've got an organization that's really good, they've defined their vision and we're all trying to buy into it, actually all any employee will ever do is that while it suits them, they will align their need with the company's. As soon as it doesn't suit you anymore, you will leave, right? No one ever really fully buys into a company's vision. They have their own goals, and so long as those both align, they will give you willingly their time and their effort and their intelligence. Okay? And that's the best you can ever hope for. You cannot, if you're in management, think that you can, more taking everybody out to play bowls and whatever is going to make us all happier. It's actually what I call compulsory fun, that. So, did you want me to tell you how to fix it? Because I can't. We're asking if we can get everyone to align. I do think that it is important to talk about purpose, right? I think that's what I've been saying. I think that too often the developers are head down dealing with problems all of the time. And there was a lovely saying. It says, when you're up to your neck in alligators in the swamp, it's very hard to remember that your job was to drain the swamp because you're just fighting the alligators, right? So, I think we're often just head down in our problems. And having sessions where, you have a proper discussion of what are we achieving. Most people feel better if they feel they're giving their working hours to something that matters. We are helping to solve, this will make healthcare better for people. This will make the check-in easier. This will make this more accessible. This will help people to reach most of the systems we do are actually useful, I hope. So if you can get that as the discussion, people get happier. And we don't just feel like we're wasting our hours and our life. And we live for the weekend. Yes.
Do you have an example of a problem where you applied systems thinking to get to a solution, like a real-world situation that you...
So, the question being, did I have a real-world example where I applied it? And for me, the one I sort of half mentioned was about training. That we tried all sorts of things. We had these workshops, every Friday, and you can have your drink, and it was all nice and sociable. But as the company got bigger, it didn't seem to be working for us. And then there was this view in the company that, surely developers are motivated to learn on their own, and we should rather get people motivated to come back with certs. Certs are the answer. So we've been through a number of stupid ideas. And we even put, you get a cert, you get more on your salary. It really didn't motivate anybody. And I think the first reaction was to blame the people. They are lazy, And it took systems thinking for me to be able to go and say the way we've designed continual learning in our organization is rotten. And to then get it better and better. And I think we do quite a good job. In South Africa, people leave jobs very, very fast. So 18 months and people move usually for the next job. So my company, we've got about 50 developers and they stay at average of 5 to 6 years. And we think we got there, right? So, but we had to stop blaming people and making it not our fault, because the thing where we like to not take the blame. And you have to eventually go and say, hang on, in this case, I am management. I hope there's a lot of senior people here. They say that people leave managers, not companies. So yeah, we've got to be brave to learn. One more. What heuristics? This is what's difficult for me, because for me, I always want to simplify. It's my urge, but it's quite hard to teach to other people, isn't it? So, we're trying to look for ways for you to think, just trying to challenge you can you find pairs? I can't tell you how to do that, because every situation is going to be different. I can tell you to trust your brain's power to make patterns of things. Because that's what have you ever noticed that you can't spot something until it moves? So we have the wonderful privilege of, going on game drives to see the lions and, these sort of things. And if you're looking in the bush, in the veld, you can't see anything, and then suddenly an ear will twitch. Now we see it. Okay. So our genetics say that the movement triggers something for us. Because when So you actually have to trust sometimes that our brains are amazing. Let them spot the pattern and see where it takes you. And if you then have to step back and say, maybe I've joined the wrong things, don't be too proud of your first solution. Surely we all know that as well. I've got some teams, especially the bright guys. Gee, they're so clever and so smart, but in other words, they love what they think up first. And we got it. We know. So I forced them. I said, no, you've got to show me 3 designs. But then when they do it, we have a much more interesting conversation, because now they've had to look at it from the other way around and try and look at it as a user, try and look at it as a developer. That's all I can tell you is try and take viewpoints. And trust your brain to find patterns. It's really good. I think I'm going to say that's the end of question session. I really thank you. You've been nice and engaged. Thank you very much.